Okay, topic 5-3, multiple step problems. Today's lesson involves working word problems, and word problems a lot of times give us trouble. Sometimes I think it's the words kind of freak us out a little bit, but hopefully after this lesson you'll feel better about solving not only word problems but multiple step word problems. If there's anything I could get you to understand in today's lesson, it would be that word problems become so much easier to solve when you stop, take your time, and ask yourself a few questions. So we're going to start with the word problem you see here I have on the slide about Milton. And if you'll just read along with me as we solve this problem. Milton's goal is to read his 400-page book over the 3-day weekend. On Friday, he read 134 pages. On Saturday, he read 206 pages. How many pages will Milton need to read on Sunday to reach his goal? So a lot of times we read problems like this and we just get frustrated and overwhelmed. But I want to help you today learn how to break problems apart and just get down to the nitty-gritty of what it's asking us to do. So if you look up in the actual problem, the bottom line question that it's asking us is found right here at the very end of the problem. How many pages will Milton need to read on Sunday to reach his goal? That's the bottom line question that we have to make sure we answer. A lot of times we don't know where to start. We don't know what to do. What I would like to suggest is underline the actual question the problem is asking you to answer. Then think about going back and looking at the information that we know. So if we look at the same problem, I just have it on another slide. If we look at the problem a little bit more in depth, we know that Milton wants to read this book over 3 days. We know it's 400 pages long. We know he's already read some of the book. If you will stop after every word problem and just either jot down or say to yourself, what do we already know? It becomes very helpful. If we know he needs to read 400 pages and he's already read 134 and he's already read 206, the real hidden question in this problem that it doesn't ask us to do, but we're going to have to do to get the answer, is how many pages has he already read? Once we know how many pages he's already read, we can subtract that from 400, and that will tell us how many pages he has left. So this problem has a hidden question, and those hidden questions sometimes throw us because they don't specifically ask that question. You have to be able to figure out what is not being asked here that I'm going to have to figure out anyway. So on Friday he read 134, so we'll start with 134. On Saturday he read 206. Now the operation we need to do obviously here is adding because he's already read all these pages. So let's go ahead and add this up. 4 and 6 is 10, 3 and 1 is 4, 2 and 1 is 3. Okay? So we have answered one step in this problem that it didn't specifically ask us to do. But the only way to get this answer, the only way to know how many pages he has left to read, is to find out how many pages he's already read. We know that the book has 400 pages. Now we know that he's already read 340. So if we simply subtract 340 from 400, we're going to know the answer to the question that it's asking us in this problem. So 0 minus 0 is 0. Can't do that, so we need to borrow from the 4 and make it a 3, which makes this a 10. 10 minus 4 is 6. We now know that Milton needs to read 60 pages in order to reach his goal. So if you think about what we did, the problem only asks us one question. How many pages will Milton need to read on Sunday to reach his goal? However, in order to figure that out, we had to answer this hidden question first. So always stop and ask yourself, is this a word problem that has a hidden question within it? Here's another question, another word problem. Maxine and Jack both work at the supermarket. Maxine worked 12 hours at her job. Jack worked 3 times the hours that Maxine worked. How many hours did Maxine and Jack work altogether? Okay, this problem also has a hidden question. There's something we have to figure out first before we can add up their hours all together. Let's go on up here and underline just so that we remember what question is it asking us to answer. When we're all finished, our answer should be to this question here. How many hours did Maxine and Jack work all together? We already know Maxine worked 12. It tells us that. So that's something that we know. For Jack, it doesn't tell us how many hours he worked, but it tells us he worked 3 times the hours of Maxine. So the first step in this problem is to figure out how many hours Jack worked. We know it's 3 times the hours that Maxine worked, and we know she worked 12. So your first step is to figure out that Jack worked. We know 3 times 12 is 36. So now we can say we know Maxine worked 12 hours. Now, because we figured out the hidden question, we know that Jack worked 36 hours. So now we can do the simple addition because it says how many hours did they work all together. Now that we know Jack worked 36, we simply add up 12 plus 36. 6 plus 2 is 8. 1 plus 3 is 4. So to answer this question, how many hours did Maxine and Jack work all together? The correct answer would be 48. Again, we had to do a hidden question and find the answer to that before we were able to add it all in together. Now let's try another one, and this time I want you to look and maybe pause the video and see if you can figure this out before we work it out. So let's set the problem up. For 3 months, a 5th grade class held a fun fair to raise money for charities. The funds raised are shown in the table. If the class divides the money equally among 30 different organizations, how much will each organization receive? Okay, so we know these are the months. Remember, always stop and ask yourself, what do you know? We know that these are the months that they had the fun fair. We know that these are the amounts of money they made during each of those months. Now, all the money that was raised, they're going to divide it equally among 30 different organizations. How would we do that? What is the hidden question in this problem? Pause just a second and see if you can add. Well, I just about gave away what we're going to do here. Pause your video and see if you can figure out what's going on here. Okay? Hopefully, you figured out that in the hidden question is to figure out how much money they raised in total or altogether before we could know how to divide them out. So all you do is you simply add up these 3 numbers to get the total amount of money raised. That is our hidden question. What's the total amount of money raised? So 5 and 5 is 10. 3 and 1 is 4 plus 6 is 10. 1 and 4 is 5 plus 4 is 9 plus 6 is 15. So we know we're dealing with money. So this is actually $1,500. Now that we know how much money they raised, $1,500, we can divide that $1,500 among 30 different organizations. And look at that. This is exactly what we did yesterday and the day before. We have a division problem with the powers of 10 with a familiar fact. Now let's remember and think back to what this represents. The $1,500 represents all the money that they raised in the fun fair. When we divided it by 30, we're doing that because it tells us in the story problem that the class is dividing the money equally among 30 different organizations. So $1,500 divided by 30 organizations. If we do our familiar problem, 15 divided by 3 is 5. Remember, when you divide, we're canceling out zeros. This one will cancel this one. There's one left with nothing to cancel it with. So now we know that in order to answer this question, each organization will receive $50. Notice here again, we had to do a hidden question. It didn't ask us to add up the funds raised. But in order to divide these funds between 30 different organizations, we had to. We had to add up and see how much we had before we could get the answer. Okay, let's look at this one. A keyboardist has a digital camera that holds 156 photos. Of these photos, 114 were taken on a vacation, and the rest at a concert. The keyboardist wants to print and mount the photos of the concert on 7 pages of an album with the same number of photos on each page. How many photos will be on each page? Now, I don't know about you, but that felt like a really long word problem. So let's make it easy, and let's start off by underlining the question that it's asking us to answer. How many photos will be on each page? Now let's go look at what we know. I know that a keyboardist has a digital camera with 156 photos. It told me that. It told me of these photos, 114 were taken on a vacation and the rest at a concert. The keyboardist only wants to print and mount the photos of the concert. So my hidden question in this problem is, how many of those pictures were taken at a concert? It doesn't tell us that. We know 114 of them were taken on vacation and the rest were at a concert. So if we subtract the ones taken on vacation, won't that leave us the ones taken at a concert? It should. 6 minus 4 is 2. 5 minus 1 is 4. Now, what does this 42 represent? This 42 represents photos taken at the concert. Sorry, that's not really good writing. There we go. Okay, let's get back to the question. Now we know that there were 42 photos taken at the concert. Here's what the keyboardist wants to do. The keyboardist wants to print and mount the photos of the concert on 7 pages of an album with the same number of photos on each page. So here's our problem. If I know I have 42 photos from the concert, and I'm going to divide those photos among 7 pages, look how easy it is to find our answer. So in this problem, our hidden question was, how many photos were taken at the concert? We had to do that first before we could divide those photos out onto 7 pages. Okay. One more problem, and we're going to look ahead and see if we can kind of summarize what we've been doing here with word problems. Okay. Faye is putting together packets of colored beads to give as gifts. The chart shows the beads she had on hand yesterday. That just means it shows the beads that were available, the ones that she had. This morning, she bought 4 boxes of yellow beads containing 45 beads each. How many packets of 60 beads can she put together? Okay, so let's kind of a complicated one again. Let's look at the question it's asking. When we're finished, we should have an answer to this question. How many packets of 60 beads can she put together? We're using these beads in our packets, but what did it tell us she did this morning? She bought more beads. We don't have a place in our chart that says yellow, so we're going to have to add to our chart the yellow beads. And it told us she bought 4 boxes of yellow beads containing 45 beads each. So in order to know how many yellow beads there are, we have to multiply that out. 45 times 4. 4 boxes, Each box had 45. Let's multiply. 5 times 4 is 20. 4 times 4 is 16, plus 2 more is 18. So our hidden question is, how many yellow beads are there? Now we know there are 180 yellow beads. Okay, and I'm going to get this out of the way so we've got more room to write. Now, back to the question. How many packets of 60 beads can she put together? Well, when I look at this, I see a whole bunch of different colors with a whole bunch of different numbers. How am I going to divide those into packs of 60? There's another hidden question. Before you can divide those into packs of 60, you have to add them up and see how many there are. With addition, it's okay to stack up all these numbers to see what they equal. Subtraction would not be okay, but with addition, it's totally fine. 5 plus 5 is 10. 9 plus 1 is 10, plus 7 is 17, plus 7 is 24, plus 8 is 32. Put down my 2, carry my 3. 3, 4, 5, 6, 7. Now, what does the 720 represent? This is all the beads. Now that we've added yellow, we have 720 total beads. Now we can answer the question. How many packets of 60 beads can she put together using all 720 beads? So think about what we're doing. We have 720 beads. We're dividing them into packets of 60. 72 divided by 6 is a familiar fact. Answer is 12. When you're dividing, you cancel. So our answer is, how many packets of 60 beads can she put together? 12 packets, because 12 times 60 is 720. 12 times 6 is 72. Add your 1 0. Okay, hopefully this has helped with word problems, and how if you just take the time to break those apart and think about them, shouldn't be that difficult to do. So we're going to skip all the way down to part 3 of your notes page. And on part 3 of your notes page, I want you to pause the video. I want you to read this problem, figure out what the hidden question is, and I want you to answer this question for me, this problem for me. It says, you earn $3 an hour as a waitress. After working 3 hours, you earn $12, $5, and $7 in tips. How much money did you earn in total? Explain how you found your answer. What I'd like for you to do is to make sure that you show me what your hidden question is. The hidden question is usually a question you have to answer first before you can even work the problem it's asking you to work. So if you'll go ahead and do that now and pause the video, you can start it back up when you're finished. All right, now let's go back up to part 1 on your video. And today on part 1 of your video, I would like for you to summarize for me what you feel like helped you the most today with word problems. Summarize what really made sense to you today that maybe hadn't helped you before, maybe you hadn't heard before. Summarize what helped you today with word problems. So it could be lots of different things, including the hidden question, stopping and underlining, anything that you can think of that you really felt like helped you with being able to work multiple step word problems. And go ahead and pause the video and fill that out in part 1. Okay? Now, we talked in part 1 about what you feel like really helped you. What I would like for you to do today in part 2 is share with me your fears. I want to know what holds you back with word problems. What fears do you have when you start a word problem? What goes through your mind? What messes you up? What kinds of things bother you with word problems? And is there something that I could explain more that would help you as you go through word problems, as we work them throughout the rest of this year? So you can go ahead and pause the video now and do that. All right. This lesson is complete. Topic 5-3, multiple step problems. I really hope we gain some confidence in working multiple step problems. We'll be working in class tomorrow on several different multiple step problems so that you can show me how you know to find the hidden questions and that you can do multiple step problems. Have a great evening.